So a student throws a set of keys vertically upward to her sorority sister, who is in a window 4 meters above. The keys are caught 1.5 seconds later by the sister's outstretched hand. A, with what initial velocity were the keys thrown, and B, what was the velocity of the keys just before they were caught. So I've underlined the two givens here, which are displacement and time. Oops. Okay, so delta x is equal to 4.0, or here it's d delta y, sorry, because we're looking at it vertically. Okay, is 4.0 meters. And time is equal to 1.5 seconds. And acceleration here, since acceleration here will be gravity, which is equal to 9.8 meters per second. And in this problem, I'm going to be defining up as positive and down as negative. So since gravity is always pointed in the down direction, it should be negative, so negative 9.8 meters per second squared. And you're finding initial velocity and final velocity. Okay. So for part A, to find initial velocity, I'm going to be plugging into the kinematic that is change in y equals v initial t plus 1/2 gt squared. And you want to isolate the initial velocity. So to do that, it becomes change in y minus 1/2 gt squared over t. And then you just plug in the numbers. So 4.0 meters minus 1/2, negative 9.8 meters per second squared times 1.5 seconds squared. And since you're squaring the units as well as this number, the seconds squared will cancel out with that, and you'll be left with meters on top. And on the bottom, just 1.5 seconds. So you should end with meters per second, which are the units for velocity. And after plugging in all the numbers, you should get 10.02 meters per second. And that's the initial velocity answer. And okay. Okay, and then for part B, we're finding final velocity. So I'm going to just be plugging that into this kinematic 1/2 displacement equals 1/2 v initial plus v final times t. And again, you want to isolate v final. So to do that, it becomes 2 delta y over t minus v initial equals v final. And then you just plug in the values. So 2 times 4.0 meters divided by 1.50 seconds minus 10.02 meters per second. And this equals negative 4.69 meters per second. And this negative in front, that indicates direction, since velocity is a vector quantity. So the magnitude is 4.69 meters per second, and the direction, since it's negative, means that it's going to be pointing down. The velocity, the final velocity will be pointing down. And that's it.